Hello Roosevelt students, this is Mr. Roble with another video lab. Today I'm going to be doing a lab with you that's called the Gravity and Inertia Lab. Just like always, this is the copy of the general Gravity and Inertia Lab. If you have the accelerated copy, it is going to look a little bit different, but for the most part, it is the same lab. If you don't have a copy of the lab, talk to your teacher, or you might be able to download it from your teacher's website or from your grade book. So there is one learning target at the top of this lab. It says, I can explain how gravity and inertia work in the orbit of an object. Whenever I do these videos, I say you might have to pause it or you might have to rewind if you miss something because they go kind of quick. So if at any point I'm going too fast, just pause it and rewind the video and make up anything that you might have missed. There is some research that you have to do here. You can get that from your notes. There is a hypothesis that you have to fill in. So if gravity and inertia did not exist, then the planets, and you should put something here, because, and again do something here. So if, then, because. So the procedure, the first part, you can do that all on your own. All you need is your pencil. It says hold your pencil above the table and let go. What happens to it? What force, a push or a pull over a distance, caused this? So you do that with your pencil. Then there are a few parts here that you have to answer. Number 3 down at the bottom. This is where it starts to get a little bit different, and this is, you're probably not going to have these supplies at home, so I'll show you what you do for number 3. It says, now you will use your model of the sun and earth. The stopper is earth, the tube is the sun, the weight is gravity. Hold onto the tube, which is the sun, with the lead weight, gravity, hanging down. With goggles on and away from other students, begin to whirl the rubber stopper. So I'm not going to wear the goggles just because I have nobody else in this class with me right now, but I'm going to have to back up and show you what it is that you have to do, and I'll explain what the different parts of the materials are. 3A says, as you whirl faster, what happens to the lead weight? So watch what happens to the lead weight when I start spinning it. B says, as you whirl slower, what happens to the lead weight? C, therefore, if any planet suddenly slowed down in its revolution around the sun, what would happen? And D, if any planet suddenly sped up in its revolution around the sun, what would happen? So again, let me show you what we have here. So this is what we're using. So I have a rubber stopper at the top. It's connected to a rope. And in the middle of the rope right here, this is a plastic tube. So you can see that the rope goes through the tube. At the other end, I have a lead weight and another rubber stopper. And the only reason that this stopper is on here is so the lead weight doesn't go right through the middle of the tube. But remember that this, at the top, this stopper, this represents the earth. This tube right here represents the sun. And this lead weight and the stopper with it represents gravity. So I'll back up, and I don't know how well you're going to be able to see this, but there everything is on the screen. Notice the weight is down here. So I'm going to start spinning this, and when I spin it, you can see what happens to the weight. So notice the direction that the weight is moving. There's a question on your lab sheet about which direction or what happens to the weight. So you can see what happens when I spin it. When I slow down, so if I'm going kind of fast and I slow down, check out what happens again to the lead weight. It goes a certain direction, and that answers a question on your sheet. And then remember that this is Earth. So if Earth suddenly slowed down, watch what happens to Earth compared to the sun. If the last part, I think it was 3D, it says if a planet sped up, what would happen to it? So let's say that this is Earth's normal orbit. What would happen to Earth if all of a sudden it sped up? Well, it would basically fly off out into space. So that is for number 3. Let's look at what we have after that. For inertia, I'll show you really quick what it is. And then for, that's for number 1. For 2 and 3, you have to kind of use your imagination, or you're going to have to rewind and look at me whirling the stopper and the tube again. And that is the stuff that you can use to answer 2 and 3. And then there are some questions at the bottom. So let's look at number 1 under inertia. It says place a note card on top of a beaker and place a penny on top of the note card and then flick the note card. So I'll show you what happens there. So I have a penny on a note card, and I have the penny on top of the beaker, or the note card on top of the beaker. The note card flew right at you. The penny ended up in the cup. If you have any questions, ask your teacher. Thanks for watching.